We measure heat transfer using a technique called calorimetry. Calorimetry revolves around the conservation of energy. That is, every joule of heat lost by a system is absorbed by the surroundings, or every joule of heat absorbed by the system comes from the surroundings. So if we fix the surroundings around our system and we carefully monitor the system and the surroundings, we can say, oh, the surroundings changed by a degree. If we know their heat capacity, we know how many joules were transferred from the surroundings. So we use heat capacities and temperature changes to monitor heat flow between systems and the surroundings, and that's the essence of calorimetry. Now, what causes heat capacities? Well, if you add heat to a system and raise its temperature, what you're doing is changing the kinetic energies of the particles. You can always associate higher temperatures with more molecular motion. So higher temperature, and I've absorbed some heat, means that heat went into increasing the kinetic energy of those particles. So, for instance, a water molecule, you can start that water molecule moving in either the liquid or the gas phase by adding some heat. It can translate or it can rotate. You can also have molecules move relative to each other, either in the solid, liquid, or gas phase. And when they do, they'll encounter some intermolecular forces that are trying to prohibit that, but they can gain kinetic energy and move past each other. More molecular motion is higher temperature. The energy you add is allowing the things to gain that kinetic energy in opposition to those intermolecular forces. Now, those are all kinetic contributions to the heat capacity. That is, I'm getting more motion for every joule of heat that I add. Well, what if I don't get more relative motion? There's also a potential energy contribution to the heat capacity. I could take those same intermolecular forces and completely overcome them. Say I take liquid water and I boil it. I completely overcome the hydrogen bonding interactions in liquid water and add energy to do that transition. Now, there I'm adding energy and I'm getting a phase transition rather than an increase in kinetic energy. That's a potential energy contribution to the heat capacity. Or I could have intramolecular bonds breaking or forming. Those intramolecular bond breaking and forming can also contribute to heat transfers in the system or the heat capacity of a system, and that would also be a potential energy contribution. Either way, whether I have these enthalpic or potential energy contributions to kinetic energy or, to heat capacity, or kinetic contributions to heat capacity, I can measure them using calorimetry.